So, in this next exercise, we must find the area between the graphs of this and this function over this interval. What we have to do first is take the difference of these two functions. Let's call that f. So we will have f of x, that is h of x minus g of x. And then this will be x cubed minus 2x squared minus 3x plus 0. Constants cancel out. And now what we have to do is very similar to what we did before. We must find the area between the graph of this function and the x-axis over the same interval from -2 to 2. And now we do what we did before. Let's consider our interval from -2 to 2 and find the zeros of our function f that are inside this interval. So let's solve the equation x cubed minus 2x squared minus 3x equals to 0, and we can see that we can factor out x, giving us x times x squared minus 2x minus 3 equals to 0, and now we have x times x minus 3 times x plus 1 equals to 0, giving us 3 zeros of this function, x equals to 0, 3 or -1. Let's see where they are compared to our interval. 0 is here, 3 is somewhere here outside our interval, and -1 is somewhere here inside our interval. So these split our interval into 3 parts. So we will have to take 3 integrals from -2 to -1, from -1 to 0, and from 0 to 2. But these give us signed areas, so we must take their absolute value before adding them up to get the area that we are looking for. And now that we know what we have to do, let's do it. We have a equals to the absolute value of the integral from -2 to -1 of f of x dx plus the absolute value of the integral from -1 to 0 f of x dx plus the absolute value of the integral from 0 to 2 f of x dx. And here we have 3 definite integrals inside the absolute values, but they have the same function f inside, so we only need to find a single indefinite integral, integral f of x dx. This is of course just integral x cubed minus 2x squared minus 3x dx, and that gives us x to the 4th power over 4 minus 2 times x cubed over 3 minus 3 times x squared over 2 plus some constant c. And now that we have found the primitive function, we can calculate our area using the Newton-Leibniz formula, which gives us, of course, the absolute value. Let's take the primitive function x to the 4th power over 4 minus 2 times x cubed over 3 minus 3 times x squared over 2 let's evaluate it at -1 and -2 and take their difference. And now let's do this with the same function on the second interval. So we have the primitive function and our interval goes from -1 to 0, and then we have our third interval, and we have to use the same function there. Going from 0 to 2. And now we just have to calculate these values. So we have the absolute value of -1 to the 4th power over 4 minus 2 times -1 to the 3rd power over 3 minus 3 times -1 squared over 2 minus, open parentheses, and we have -2 to the 4th power over 4 minus 2 times -2 cubed over 3 minus 3 times -2 squared over 2. Close absolute value, and then we have the absolute value of 0 to the 4th power over 4 minus 2 times 0 cubed over 3 minus 3 times 0 squared over 2 minus -1 to the 4th power over 4 minus 2 times -1 cubed over 3 minus 3 times -1 squared over 2. And let's not forget to close the absolute value, and then we have the third interval, and here we have 2 to the 4th power over 4 minus 2 times 2 cubed over 3 minus 3 times 2 squared over 2 minus 0 to the 4th power over 4 minus 2 times 0 cubed over 3 minus 3 times 0 squared over 2. And you can end the exercise here.